So in this video today, we will be looking at graphing of continuous linear functions. If you haven't seen the video on graphing discrete linear functions, please take a look. It's in the same playlist. If you haven't seen the other videos on linear functions, I recommend those as a background. But here we will basically look at one example and learn what it means when we say that we have a continuous linear function. So what do we mean by continuous? Well, what we're saying is that our domain, which is the set of numbers that we can use as input, and our range, which are the set of outputs, are both continuous. And when we say continuous, what we mean is that if there are 2 points on the number line that are included in our domain, any number between those 2 numbers will also be part of our domain. And the same goes for the range. In the case of a linear function, if we have a continuous domain, we also have a continuous range. We can't have jumps or discrete points in our range if our domain is continuous. So let's look at this example. I wrote down the functional form here, y equals 120 plus 1.03 times x. So here x is our input and y are our outputs. And let's look at what this linear function describes. So we're looking at the weight here of a glass of milk. And the glass of milk consists of the glass itself, which weighs 120 grams right there. And it contains milk. And the milk has a density of 1.03 grams per milliliter. And X here is the amount of milk in volume or in milliliters. So milliliters is a unit of volume, and when we multiply the volume here by the density, we get the weight or the mass, really. So X is the amount of milk we pour into the glass, and we measure that by milliliters or cubic centimeters, which are equivalent. And then we take the total weight to be equal to the weight of the glass right there, 120, and the weight of the milk, which is given by that product. So we can look at a few examples. Let's maybe erase all this around our equation so we can look at a few examples. So let's say we take 100 grams or 100 milliliters of milk. In that case, our total weight is 120, right, for the glass, plus 1.03 times 100. In other words, we have 120 plus 103 grams, or 323 grams. So that is when we take 100 milliliters of milk. Let's look at another example. Let's say we take 200 milliliters of milk. Okay, that's nearly a cup. A cup is about 250 or 240 milliliters. So say we take 200 milliliters of milk. Our total weight, y, is 120 for the glass plus 1.03 times 200. In other words, 120 plus 206, or 326 grams. Okay, so let's go ahead and draw this, graph it. Now, similar to the discrete example we did in the previous video, we don't have to go to the negatives. We're not going to add a negative amount of milk, right? So if X here is milk in milliliters, and y is total weight, So let's start at 0 milk. So if we've included 0 milk at the origin here, what we get is 120, right? Say this is 120. So our first point is here. We only have the weight of the glass contributing to the overall weight. If we go to 100 milliliters here, now we know that we have 323 grams, or really should be 223, not 300, because we have 120 plus 103. So 223, let's put that over here, and this is not going to be perfectly exact, but we're just going to draw it kind of roughly. Let's also look at the point, 200 milliliters, and then we have 326 grams, and I'm going to put that right there, 326, right? So overall, now we have these 3 points here, but I've put a line through them. Why was I able to put a line through them? Because we can actually put any amount of milk between 0 and more or less a cup. So this is about a cup of, let's say this is a full cup. So this is our domain, right? Our domain is from 0 amount of milk from here, 0, all the way to 200 milliliters. But we are allowed to take any point in between. We can put that much, we can put 50 milliliters, 150, and any other point on the number line between these 2 points here. Okay, so that gives us a continuous domain. As a result, we also have a continuous range, because the weight of our glass of milk now can range between 120 and 326 here, and we can get any value in between as long as it satisfies this function that the total weight is equal to the weight of the glass plus the weight of the milk as is given by its density. So this is an example of a continuous linear function where we said we're allowed to go from 0, including, our range is from 0 all the way to 200 milliliters, including the endpoints. That's our domain. And our range now, as a result, is continuous from 120 all the way to 326, including, in gram here, including the edge points. So it is a continuous domain and a continuous range, which are different from the previous example where we had discrete weights of pennies or coins. So that's it for this video. If this has been helpful, please like. Check out the other videos for linear functions, and I'll see you next time. Thank you.